A proton moves at the speed of 1.4 times 10 to the power of 3 meters per second in a direction perpendicular to a magnetic field with a magnetic of 0.85 Tesla. Calculate the magnitude of the magnetic force on the proton. What would be the magnitude of magnetic force be if the particle were an electron? Let's find out part A first. How to find out magnetic force? We have the relationship between B, V, Q and sine theta. Magnetic force in terms of Newton, magnetic field strength in terms of Tesla, velocity of the charged particle in terms of meters per second, and Q is the charge of the particle in terms of Coulomb. Sine theta. Theta is the angle between magnetic force, magnetic field direction, and velocity of the charged particle. In this case, it says they are perpendicular, so it means that sine 90 and it's going to be equals to 1. So F equals to B, which is given 0.85 Tesla, V, velocity given 1.4 times 10 to the power of 3 meters per second. Q is going to be the charge of the proton. Proton charge is 1.6 times 10 to the power of negative 19 Coulomb. So 0.85 times 1.4 times 10 to the power of 3 times 1.6 times 10 to the power of negative 19. The answer will be 1.9 times 10 to the power of negative 16 Newton. So that's the magnitude of the magnetic force. Now part B, it says, what is the magnitude of the magnetic force if we were dealing with electron? That's exactly is going to be the same thing, because the charge of the electron is the same as the charge of the proton. The only difference is the direction of them. So F in the second case, we don't need to go through the calculation again. It's going to be 1.9 times 10 to the power of negative 16 Newton. Now let's see the next example. An electron with speed of 235 meters per second moves through a magnetic field of 2.8 Tesla. The magnitude of the force on this electron is 5.7 times 10 to the power of negative 17 Newton. What angle does the electron's velocity vector make with B? So the relationship between magnetic force and magnetic field, velocity and charge, and also the angle is going to be using this formula. F is the magnetic force, magnetic field direction, velocity and charge, and times sine theta. We had it in the previous example. So F is the force, which is 5.7 times 10 to the power of negative 17 Newton. B is 2.8 Tesla. Velocity is 235 meters per second. We are dealing with electrons, so it is 1.6 times 10 to the power of negative 19 sine theta. So sine theta will be 5.7 times 10 to the power of negative 17 divided by the multiplication of these three numbers. 2.8, 239. That's going to be 1.05 times 10 to the power of negative 60. So we have 0.54. So theta will be inverse of sine 0.54. That will be almost 33 degrees. So that's the angle between the velocity vector and the magnetic field direction.